Welcome to the Dusty Jobs podcast from Imperial Systems. Industry knowledge to make your job easier and safer.
Hello, and welcome to another episode of the Dusty Jobs podcast. We're glad to have you with us. Today in the studio is Joe Hunt. How you doing, Joe?
Oh, fantastic today, Donovan. Thanks for having me here.
Great. Joe's actually our very own Imperial Joe here. And Joe, tell us about yourself. You've been helping out with filters for, man, how long now? How long have you been doing this filter gig?
Now you're going to date me, Donovan. Come on now. You know, I've been in the industrial air filtration market for over 25 years, going back to the 90s.
Yeah.
Donovan.
So you have a little bit of knowledge in this field.
A little bit of knowledge on the filter side of the business. That's here, right. For sure.
And that's what Joe's here talking to us about today. It's going to be talking about, I think we're going to call this Filters 101.
Filters 101, I like that.
Yeah, just for anybody out there who's trying to maybe understand a little bit more about the filters that are going into their dust collector, or maybe you've been tasked with getting a new set of filters or something like that. We're going to try to help give you a little bit more knowledge of what you're looking at, because, man, this doesn't come up often for a lot of people. Maybe once a year or every 2 years, right?
Yeah, it could be anywhere from 6 months to a year or two, and sometimes in gas turbine, we've seen them run for 8 to 10 years.
Yeah.
That's a little bit of different industry, but those filters are being used there as well.
Right. So if this is your first time buying, or you're just trying to figure out what you're looking at, that's what we're going to be talking about today. So, but Joe, tell us a little bit more about yourself. You're here, you came on board with Imperial, and you're really helping. What aspect are you helping out with here?
Well, I'm working on really a business development, working on the channel distribution, trying to expand that portion of the business with Imperial for aftermarket dust collection filters.
Yeah.
You know, my experience goes back to I started out with Donaldson, and that was more of the media side of the business. Worked there for 7 years, and then took a job with Clarcor and started up their cartridge business at Clark Filter.
Right.
And that's where the cartridge portion of the aftermarket really started to grow.
Yeah. So you mentioned that you used to do media. So when we're talking about media, we're not talking about, television or things. We're talking about filtration media. That's right. So that's the actual material that goes in the filters. That's what's doing the filtering.
Correct.
I guess is good to say.
Yes.
So, but there's, how many different types are there out there?
Many, many different types. You start off with a paper type of media, and then you can go all the way up to different types of exotics, where you go from low temperature, low efficiency, to high temperature, high efficiency.
Oh, wow.
Types of exotic materials that are out there. And
so
there are different ones that are coming out each year.
So exotics would be for a very specific application.
Right, very, very niche market.
Gotcha. So probably if you're buying that filter, you'd know a little more about that. So
yes.
let's just talk about what are the basic medias that people might be running into when someone's out there, like I said, maybe they're trying to buy a filter for the first time, or they're looking at a collector and they're trying to decide what's best for their application. What are some of the more basic ones that people will get into?
What we see mainly are what is considered a paper type filter. And this would be a filter made of 80% cellulose and 20% polyester.
Gotcha.
Okay, and then you have different variations of that. So you have the 80-20 paper, and then 80-20 FR, which is fire retardant.
Gotcha.
Okay, and then from there, that is the lower level. That's more of a commodity type media, and then you go from there and you start upgrading. And from that point, that's the lowest cost, but the lowest efficiency as well.
Gotcha.
And the lower performing filter.
Okay.
From there, we start stepping up. We go from there to a Nanofiber with FR, and then that's for more tougher applications.
So you're saying Nanofiber?
Nanofiber.
What does that mean? For somebody who doesn't know what that means at all.
A nanofiber is a coating that they put over the top of a certain type of substrate, which would in this case be an 80-20 paper.
Okay.
So what it is a very fine nylon fiber that goes over. It's invisible to the human eye. So It's only a couple micron wide. And what it does is it really puts a surface coating on that media.
So wait, let me ask you a question real quick. When you say micron, now that's, I mean, I know that's a unit of measurement, but give me something to compare a micron to.
All right, so a coarse human hair is about 80 micron. So if you take your hair, pull it out, and look at it, that's about 80 micron. These fiber diameters are maybe 2 micron, 1 micron. So you can't see it with
80, almost 80 times smaller than your hair.
Yes.
Okay, all right. So we have our basic paper, and then we're putting this material that is so small you couldn't even see it without a microscope.
That's right.
On top of it.
That's right.
And that's called nanofiber.
That's nanofiber coating.
And it does?
Well, what it does is it protects that paper. It keeps the dust from penetrating into your paper.
Huh.
So all these filters that we manufacture, the collectors that we manufacture, are back pulsing style collectors.
Gotcha.
And what we want to do is we want to keep that dust on the outside of the filter. So when we're back pulsing, that dust blows off, drops down into the hopper.
So the pulse goes on the inside of the filter and knocks everything off.
Knocks all the dust off.
Okay.
So what this does is it allows a natural dust cake, so that the particles don't penetrate the paper. Mm-hmm. And it's kind of like your Teflon frying pan.
Oh, I gotcha.
You know what I mean? Your egg is in there, it slides around. It'll keep that dust on the outside, pulse, boom, drop it in.
Gotcha. So you're saying if I got the nano fiber material on it, it's going to help that filter clean off better and hopefully last a little longer?
It'll definitely last longer than a standard commodity 80/20 paper.
Right.
Absolutely.
So if there's somebody out there and they're seeing really short life out of their filters, possibly this could be a solution to help them have a longer life out of their filters.
Oh yeah, absolutely, absolutely. It's one of the best available technologies we have out on the market right now in filtration media. Now that's not to say we're not working on new medias to bring to the market, but right now the nanofiber is very useful for many different applications.
So what's some dust that I would say I don't want to use this regular 80/20 paper on, but I should definitely be thinking about doing this nanofiber on? What would be an example of something that would be, oh man, you don't want to use regular 80/20?
Well, the 80/20 is great for general uses. You know, when you have particle sizes that are much larger, so you've got wood dust, cement, stuff where you have very large particles.
Gotcha.
Now, when you get into welding, weld fume, plasma, laser cutting,
right,
that's where you're going to have smoke, which is very, very small particle sizes.
Yeah.
And the nanofiber is head and shoulders performance level over an 80/20 in those types of applications. So if you have submicron, anything less than 10 micron particle size, you definitely want to use a nanofiber.
So not only is it cleaning better, but it's helping capture better also.
Right, your emissions go way down.
Oh, wow.
Yep, absolutely.
Now, okay, so we got those two. Now, you're talking about, now I've heard this term out there, and a lot of people ask me about it, and it's Merv, the Merv of the filter. Now, there's a Merv rating on filters, and I know this is a term that gets thrown around a lot in the industry, and maybe you could unpack what that means for someone who's just trying to figure this out for the first time.
Yeah, so the Merv rating, I mean, it goes back to the ASHRAE 52.2 test.
Okay.
And it is a static test and it was really developed more for the residential type of HVAC type of filters.
Gotcha.
Where they are non-pulsable filters. So it's a static test where you have a media and you present a air.
Yeah.
And then you present particles into the airstream. And then you test how efficient the filter media performs against those different sized particles.
Gotcha.
So the less efficient, you have a lower Merv rating.
Okay.
So it starts down at a low Merv 6, and then as you move upwards in efficiency, where our media is like a commodity type 80/20, like we talked about earlier.
Right.
That's going to be about a Merv 10, somewhere around there, 9,
Okay.
10. And then as you move into the nanofibers, there are different varieties out there, but our nanofiber is a Merv 15. So the efficiency definitely takes a rise when you add that coating of nanofiber to the filter.
So the larger the Merv rating,
The more efficient.
The more efficient it is.
Yes.
The lower the Merv rating,
The
the
less,
less
efficient.
efficient it is. So like when I get my furnace filter in my house,
Yes.
that's going to be like a 6 or a 7,
Right.
just kind of to catch the cat hair and the lint going through.
Correct.
But if I'm trying to get weld smoke,
Yes.
that furnace filter is not going to do it for me.
Nope, it'll go right through it.
Right. So that's where they came up with this standard of Merv to try to help.
Minimum efficiency rating value
Gotcha.
is what it stands for.
And now something interesting you said that when they test this, it's on just a static system. It's just how much can actually get caught in it. It's not.
Yeah, so it's not actually like our filters are being back pulsed.
Right.
During the life of the system, of the filter itself. This test is just a static where there is no back pulsing taking place.
I gotcha.
So it gives you a good initial efficiency rating, but it doesn't give you that true look into how that filter is going to perform in the field.
So is there, not to get too deep into the weeds because we're on 101, we're not getting into the advanced levels here. But
That's right.
Is there other?
There is a Ashtray 199 out there that will test a filter based on the performance in a dust collector.
Okay, so this would be a separate test, a separate form of measurement.
Yes.
To give you a rating on maybe more of a dust collector filter as opposed to just like a.
It
filter
can
in
give
your
you it can give you the performance of the collector and the filter.
Gotcha.
So
it kind of it's like a hand in glove situation.
yes,
I gotcha.
yes.
So if you're really getting into it, maybe when Joe comes on next time, if we do a 102, we can do
102.2.
That's right. We'll get a little more into the weeds on that. But so that's great. That's great. So okay. So now I know if I'm going to buy a filter for the first time, I know what kind of material I'm looking at. I kind of understand my ratings now. Now I want to know when I'm looking at I'm talking for someone who's never bought a filter before, possibly. How are they going to know whether this filter that's A is better than filter B, or maybe this one's $10 more than this one? How do I even tell what I'm getting and why should I pay $10 more for it possibly?
Well, I mean, when
How
you
do I
start
evaluate that?
When you start looking at a filter, you've got the end caps, you've got expanded metal, inside, outside. You have bands, you have different types of plastisols and urethanes.
Slow down.
What?
We got people here who probably never, maybe they've never even seen a filter. So you're starting to talk about these are all the parts of the
The
filter?
components of the filter.
Okay.
The anatomy thereof.
Okay. So when someone's looking at it, let's start at the top and move down through. So the first thing, if I'm looking at a filter, is going to be
You're probably going to look at the gasket.
Okay.
Right? You're going to look at the gasket first. And there are different types of gaskets
now that's
available.
that's going to be the seal
The
on the
seal
top.
that the filter is going to seal into the tube sheet.
Gotcha.
Against.
Yeah, it's going to, or press against another filter.
Or
right?
press against another filter.
Okay, so we're going to look at that. So
Yep.
when I'm looking at that, what am I looking for?
So there are different types. Polyisoprene is a standard.
Okay.
But what you want to see is a nice closed pore gasket.
Okay.
Something that's gonna have some good memory to it.
I gotcha.
All right. Something that's not gonna, once you push it against that tube sheet, it's not gonna form a very small and tight gasket.
Gotcha.
You want a very nice seal.
Tempur-Pedic version.
You want that to expand.
Yeah.
You want to be able to pull it out and that gasket to still have some expansion to it.
I gotcha.
Absolutely.
Yeah.
The next thing you're looking at is the end caps.
Okay.
And
now that's what the gasket's going on. That's the piece of metal.
Going on the piece of metal.
Okay.
That's holding the filter together.
I gotcha.
Okay.
Yeah.
And the filters that we make here all have metal end caps on either side.
Right.
And what that does is it allows the paper or the media inside the filter to be potted.
Okay.
So you've got a cap on either side. Now, wow, we can get into all the different types of caps out there. Each OEM really has a different style.
I got you.
And that's a tough part of being in the aftermarket, is we have to specialize in all these different types of filters that are out there.
Yeah.
But getting back to the caps, to see a good filter, you want a nice heavy cap. There are ways to save money while manufacturing. But one thing Imperial does is we go all out. We are building tanks here.
Right.
So we have nice deep caps so that we can get the potting compound in there, and we're not skimping on that potting compound
now you're
to
saying,
keep the media.
So we're talking
together.
about the end cap, and then so it's kind of like the rim around the top.
The rim around the top.
And the bottom.
Yep.
And now you're using this word potting compound.
Correct.
Now what is that? Is that the
So we're using
glue?
a urethane. It is a glue.
Okay.
You can think about it. It's a urethane that we take the cap, and now we fill the cap up with urethane.
Right.
And then we put the media down into the cap.
It's like planting the media into the thing. So potting compound. I don't know if that's where they came up with that, but
It's like potting a plant.
Yeah, like potting a plant. We're
There you go.
potting the media in there.
Absolutely.
I got you. I'm with you. I'm tracking. Absolutely. Okay. So then there's one that goes on the top.
Yep.
There's one that goes on the bottom, and then this potting compound. I mean, can I even tell? Like, how would I know what I'm looking at? Or is there something I should be looking at when I see that, or when I'm examining?
Well, you just want to make sure, like what we do here is we put plenty of potting compound in there. You want to see it rise to the top of the cap because it has to enclose each pleat of that media.
Okay.
Or else you're going to get bypass. And that's what happens with some of these filters. They'll go into the field and they won't be potted correctly. Either they're using, off-brand caps, or they're not putting enough either plastisol or urethane in there, the potting compound.
Right.
And you can get bypass. We're talking about, air streams with submicron particles in it.
Right.
You have to make sure that filter is potted on both ends and that all those pleats are secure, held in there,
right,
so that there's no leakage.
Yeah, so that's just another place that everything needs to be sealed up well, so it's a potential fail point.
Right,
I guess.
absolutely.
So to make sure, if you're looking at a filter for the first time, it's your job. You're out there and they're saying, well, is this a good filter? That's something you could look at and look down into the caps, look into the pleats, and see if there's gaps, or if there's maybe it doesn't look like it's filled up all the way.
Correct.
Those would be some good telltale signs that
you have a good quality filter.
Or you don't.
Or you don't.
That's right. So then we have the top, we have the bottom, and the middle is
it's the media. Now that's the heartbeat.
Right.
That's the heartbeat of the filter. That's the portion of the filter that's doing all the work. So that's the filtering mechanism.
Gotcha. But if there's just media there, wouldn't that filter just collapse? Is there anything that's giving it some structure?
It will, because that media is, like you said, if it didn't have any support mechanism,
right,
it would just collapse on itself.
So
what we have is expanded steel on the inside.
Okay.
Because remember, these things are getting back pulsed,
right,
but they're also getting a lot of negative pressure.
Oh, that's right.
So all that air, that dirty air is hitting the outside of the filter.
Mm-hmm.
The clean air is coming through the inside and going out
through
the system.
Yeah.
So we have expanded metal on the inside, and it gives a nice, sturdy, it's like a spinal cord to the filter.
I gotcha.
Yeah, absolutely.
Yeah, it's rigidity.
The rigidity of the filter.
Right.
Right. And that's very important, to have a nice, heavy interior core, what we call an inner core of the filter.
Yeah.
Now, you talk about the inner core, we got to talk about the outer.
Okay.
Because again, you're getting that negative pressure, which could collapse a filter. And then you're having these filters back pulse with 90, sometimes you've ramped up to 100 PSI. So you need something to keep that filter from ballooning.
Gotcha.
So, and we talk about expanded inner, we have expanded outer as well.
Okay.
And then we've got other options where we have a nice cording, a Helix cording machine that puts a cord around it. It's more open than an expanded steel outer.
Okay.
So it allows the filter to clean a little better. But what it does is it keeps the filter together and allows for it to still clean without ballooning and exploding.
Right. Now, I've seen that on the filters here. It's almost like a shoelace design.
Yes.
Like it's like wraps it around so that it keeps it, but it's still, you're right, it leaves a lot of the material exposed so that it can do. Now, some of them I've seen them with bands.
Correct.
That's another method, right?
That's another method. You can have polyester, nylon, woven bands on the outside.
Okay.
Yes.
And then there's the actual metal, like you said too.
Yep.
Now,
Expanded.
is the reason for doing it one way or the other? Could that come down to the application? If someone's saying, "Well, how do I know which one do I need?" What?
Yeah, it is more application specific.
Okay.
The outer expanded normally is used in an application where you have finer dust. When you get to a more fibrous dust, you want to use something that's more open. And that's where you would use the banding or the cording.
Gotcha.
And really, in all honesty, you could use the cording all the time.
Okay.
I mean, it does give that good support.
Right.
And it allows it to clean. I think, and what we have seen here, it cleans better than the outer expanded.
Well, that's good to know, because the cleaner your filter is, the longer it's going to run, right?
Yeah, well, we don't want them to last too long, Donovan.
Well, that brings up a great question. How do I know when it is time to change my filter? Should I open the door and look at it? Is that going to help me? What's the way to tell?
Well, most places will have a PM set up, and they'll change at a certain pressure drop. So as these filters are being loaded over a certain period of time, pressure is building up in the system. So they start out clean, so it's a low pressure drop.
Okay.
Over time, the dust is building up, the filter is losing its performance, and your pressure drop will rise.
I got you.
And some companies will have it set at 8 inches of water gauge to change the filter out,
okay.
or 10. Normally we see between 6 and 8 is where you would change your filter. But in reality, when you really want to change your filter, some of those gauges we've seen in the past have gone off. Okay. Where your pickup point is, this is very important. When you are not picking up, so if you have a grinding or a welding application, and you are not evacuating that dust,
right,
or smoke, or it's very little evacuation, that's when you want to seriously start looking at changing your filter. Oh, yes.
Yeah. Now, when you're talking about looking at that pressure, am I looking at that when the machine's running, when it's not running, like before it cleans, after it cleans? When's the best time to evaluate that?
When it's running.
Okay.
Absolutely.
And
Absolutely.
Then when it's cleaning, or when it's not cleaning, when it's done cleaning?
Well, however the equipment is set up, whether it's on time or it's on demand.
Gotcha.
Once that cleans, that's just a millisecond time of a shot of 90 to 100 PSI.
Yeah.
So that gauge is only going to move a little bit. It's
gotcha.
not going to drop from 8 to 4.
Okay.
Yeah. Over time it could change, but after a quick cleaning cycle, it's like a shotgun blast.
I gotcha. So if there's a maintenance person out there listening to this, and they're thinking, oh man, I put these new filters in, and they open the door and they look at them, and they're like, I just heard it clean, and these things are covered in dust still.
Yeah.
Is there something wrong with their filter? Is the machine operating wrong, or?
No, and we've talked about this, and both of us have had calls before saying, hey, look at my filter's dirty. These are supposed to be cleaned off. You're saying
right.
Once it's pulsing, it's supposed to clean off. Even when the filter is in there and it's in there for a certain period of time, it'll establish a dust cake. So it's going to look dirty.
Right.
The filter will look dirty.
Okay.
And it's just a natural dust cake on top of it. And that's kind of how it performs. And that helps, along with, say, if you have a nanofiber, you've got a natural dust cake on top of the nanofiber. It keeps those larger particles from penetrating and getting inside of the media itself.
So it's actually helping the filter to work better once it gets, I know what we call it, seasoned.
Yep.
It has a little bit of the dust on that initial dust gets on it, and it actually makes it work better.
And it'll get more efficient. Absolutely. Even the Merv 15 will be more efficient once it gets what we're talking about, seasoned or pre-coated or coated in the system. Absolutely.
So if you're listening out there and you got a brand new filter and you open the door and you're worried, don't have a heart attack. That's what it's
working.
That's right. That's what it's supposed to look like.
Yes, absolutely.
So then basically your pressure and your pickup is going to let you know when you need to get a new filter, right?
Yes.
So those are the two key indicators. If your operators are saying, hey, this thing is just not doing what it's supposed to anymore. Or if you're watching your pressure gauge or monitoring that daily, that's going to also give you a good key indicator on that specific unit.
Yeah, I mean, that's what it's there for. It is to give you that heads up, like, hey, it's time to change the filters.
Right.
And your owner manual will tell you normally when that is. And each collector is different. Each application is different.
Right. Well, Joe, I just want to say thanks for coming on. I appreciate it. I know you got way more knowledge, so we're just scratching the surface here. So if you're listening to this and you have other filter questions or need a filter, feel free to call in. We have a whole team of people here with a lot of knowledge, and we'd be glad to help answer any other questions you have, or if you need anything else. Like Joe said, we do build them here, we sell them here, so we have a lot of knowledge in what we can help you out with, and that's it. Just saying thanks for coming on.
No,
again,
thanks.
Joe.
I can't wait to come back for 102.2.
102.2.
And I'm really excited about the ice cream as well.
That's right.
You promised me ice cream.
It'll be coming after the show.
All right. Awesome, Donovan. Thank you.
But I just want to encourage everybody, if you're not doing it already, to follow us on Instagram, Facebook, LinkedIn, Twitter. You can find us on iTunes, and all of our old episodes are on YouTube also. So I'd encourage you to like and subscribe us there. So until then, stay healthy and stay safe, and we'll talk to you next time.
Hit that like button.
Thanks for listening to the Dusty Jobs podcast. Breathe better, work safer.